You know the drill. You get your hands on a powerful, state-of-the-art foundation model, you give it a whole set of tools, and you're expecting absolute magic. But instead, you get this. A brittle, unreliable agent that just completely breaks down in any kind of complex, multi-turn conversation. I mean, we've all been there, right? It's this shared frustration. You build an agent that works perfectly on the first turn, but then it just falls apart. The second the conversation gets deep, the second context really starts to matter, when the real work is supposed to begin, it just fails. So what gives? The answer isn't just, throw a bigger model at it. The answer is having a much, much better playbook. So today, that's what we're going to do. We're going to build that playbook by diving deep into a synthetic of some really cutting-edge research, and we're going to start with the very first pillar. Right, so the first pillar of our playbook, and you could argue it's the most important one, is the data itself. If you want to build truly reliable agents, it all starts with a rock-solid foundation of high-quality, specialized multi-turn training data. And, well, getting that data is a real challenge. This quote right here, it reveals a massive, fundamental shift in how we think about this. State-of-the-art data generation isn't about simple web scraping or basic prompting anymore. No way. It's now a sophisticated, multi-stage pipeline that actually uses agents to create better data for other agents. It's this incredible system that mirrors the very complexity we're trying to teach in the first place. Let's look at how this actually works with a framework like APIGen-MT. It's super smart. It decouples the problem into two distinct phases. First, it creates a verifiable blueprint of all the correct tool calls. Now, this is absolutely crucial. It makes sure the underlying logic is perfectly sound before a single word of conversation is even generated. Then, and only then, in phase 2, it simulates a natural dialogue around that correct blueprint. That's the decomposition and verification pattern in action. The button framework takes a slightly different but just as powerful compositional approach. It starts bottom-up by building these complex, solvable tasks out of simpler, pre-validated atomic units. Seriously, think of it like building with Lego bricks. You already know each individual brick is solid, so you can build these massive, complex structures with total confidence. Then it works top-down to generate the conversation, making sure the agent learns how to properly break down the problem. So the big takeaway here, when you look across all these frameworks, is the trend they all share. Every single one of them is moving away from simple, one-shot data generation, whether it's decoupling the logic from the dialogue like APIGen-MT or building from the ground up with validated units like Button. The end goal is exactly the same. Create these structured, verifiable data pipelines that guarantee quality right from the very beginning. Okay, so you've got the high-quality data. Awesome, but that's only the first part of the playbook. The system you build around the model, its architecture, is just as critical for creating a reliable agent that doesn't fall over. And we're seeing two main paradigms really emerge here. On one side, you've got single-agent systems like React or Reflection, where one big LLM does all the thinking in one unified context. They're simpler to build, for sure, but they can hit these cognitive bottlenecks. Then, on the other side, you have multi-agent systems that delegate tasks to specialized worker agents. It's incredibly powerful, but it also introduces communication overhead. But here it is. This is the most important insight from this whole section, and honestly, it's a total game changer. The raw intelligence of the core LLM you're using, it's not the primary thing that determines reliability. It's the engineering. It's the framework you build around it. And this just illustrates the point perfectly. Think of the LLM as your engine. You could have a Formula One engine, but if you stick it on a flimsy wooden go-kart frame, it's completely useless, right? It's going to fall apart. But a smaller, well-tuned engine on a robust steel chassis with great suspension and steering, that's going to win the race. And that chassis, that is your architecture. It's the components like memory, planning, and especially error handling. These right here are the non-negotiables. You need advanced planning to break down complex tasks. You need sophisticated memory management to handle those long, multi-turn conversations. And, most critically, you need robust error handling. An agent that gets a detailed error message and knows how to try again is infinitely more valuable than a more powerful agent that just gets a generic fail signal and gives up. This is what separates fragile little prototypes from real production-grade systems. Okay, we have the data, we have the architecture. The final pillar of our playbook is how we actually train the model to use all of this intelligently. This is where we shape the agent's actual decision-making abilities. You know, the whole story of agent training is really a story about the feedback signal we give the model. We've been on this journey from giving the model really simple, low information feedback to providing it with complex, almost human-like guidance. So let's just walk through this evolution. We started way back with behavioral cloning, which is basically a binary signal. This path is good, copy it. Then came reinforcement learning, which added a scalar reward signal, a number. That was better, but still pretty low bandwidth. Preference optimization, like DPO, took it a step further to a comparative signal. Trajectory A is better than trajectory B. And now we're at critique-guided training, which uses a full natural language signal, the richest feedback you can possibly get, explaining why something is better and how to improve. So, does all this specialized training on high-quality data actually work? Is it worth it? Well, the proof is right here. On the really tough multi-turn Berkeley function calling benchmark, the massive GPT-4o scores about 41%. But look at this. The XM2 model, which is a much smaller llama model that's been specifically fine-tuned on this type of data, it achieves over 69%. This isn't just a small improvement, it's a monumental leap. It proves that specialized skill, not just raw scale, is what creates truly reliable agents. So let's bring all three of these pillars, the data, the architecture, and the training, together into one single actionable workflow. This is it. This is the integrated playbook. So here is the integrated workflow. First, you generate that high-quality data using a verifiable pipeline. Then, you build robust architectural scaffolding around your model, focusing hard on memory and error handling. Third, you train that model with a multi-stage regimen, starting with supervised fine-tuning and then moving to more nuanced preference methods. And finally, you close the loop by relentlessly evaluating your agent on tough, dynamic, multi-turn benchmarks, because that feedback flows right back into improving your data and your architecture. It's a continuous cycle of improvement. At the end of the day, building reliable agents is a systems engineering problem just as much as it is a modeling problem. It really requires discipline across data, architecture, and training. So my final question for you is, what are the biggest challenges you're facing in your own agent builds? Let's talk about it.